Okay, so review. Today is the 17th, 2/17/22. Well, if you want to work ahead, that's fine. I'm just going to work through this with everybody. So whenever I see a negative exponent anywhere, the first thing I do is draw a fraction bar. Fraction bar, because I know that I need to move certain numbers. I'm going to move my 4 to the negative 3 down and make it a 4 to the positive 3. So if it's a negative exponent, it needs to be either moved up or down to make it positive, okay? Y to the negative 1, I'm going to move it up to a y to the positive 1. And anything to the 0 power is the number 1. All right, that's pretty close to being done. I don't need the 1, but I'll leave it there anyway. 1y over, well, this is 3 times 3, which is 16 times 3, which is 64. There's my answer. Okay. Number 2, I see a negative exponent, so I make a fraction bar. I'm going to bring down the 2 to the negative 4 and make it a 2 to the positive 4. So if it's a negative exponent, I move it to make it a positive exponent. 2 to the third is a positive exponent, so I'm going to leave it where it's at. Two ways to do this. You could probably use a calculator. I'm just going to use my brain. 3 of these 2's will cancel 3 of these 2, because 2 times 2 times 2 over 2 times 2 times 2 times 2. 3 of these cancel 3 of these. So on the bottom, I'd have a 2, 1, 2 left over. And at the top, I'll have a 1 because of all the 2's divided by 2's. All right, number 3. Very similar to what we saw in our warm-up. Okay, so the very first thing I'm going to do is draw a fraction bar because I see a negative. To make it easy, I'm going to apply this negative right here. Calvin, this one, like the one you did. I'm going to move the 2a to the third up and the 1 to the bottom. So I applied the negative exponent, I moved the 1 down, and the 2a cubed up, and I still have it to the 5th power. Not a negative 5 anymore, but to the 5th power. Okay, so this will give me a 2 to the 5th power, because 2 to the 5th power, and a to the 15th. Over, well, 1 times 1 times 1 times 1 to the 5th power is just 1. I don't really need the 1, but there it is. All right, I'd like to tidy it up a little bit more because I know what 2 to the 5th power is. I can do that. I know what 2 to the 5th power is. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So 2 to the 5th power is 32, a to the 15th. Over 1, but you know, over 1 is kind of redundant, so I'll just leave the 1 alone. You could put it over 1. You could, but I don't want to. How am I doing? Thumbs up? I'm not going too fast? Okay. Okay, number 4. Actually, Calvin, this one, the one you did, isn't it? Yeah. Cube root, right? Negative 27 squared. There's my root, and there's my power. Cube root of negative 27. Let's see, what times what times what? Well, it's got to be 3. Negative 3 times negative 3 times negative 3 makes the cube root of 27. So I did this. I didn't do all of the problem. I've only done this part. I took the cube root of negative 27, but I still have to square it, don't I? I still have to square it. And then negative 3 squared is negative 3 times negative 3, which is a positive 9. Is this helpful? Is this helping you guys? Good. All right, number 5. Number 5 is actually pretty easy. I see a negative exponent, right? So what's the first thing I should do? Say it. Okay, so I need a fraction bar to bring it down. You're right. I need a fraction bar so I can bring it down, right? So put fraction bar. And Scott's right. I'm going to bring down the x to the negative 7 to make it a positive exponent. So bring it down to make it a positive exponent. X to the positive 7. Now the 12 is just a regular 12. 12 is a regular 12. Don't move it. Y to the 6, it's a positive exponent. Don't move it. This problem we can't simplify any further. We can't do any more to simplify. We're done. This problem is finished. We're done. Can't do anything more with it. Okay, number 6. Well, this is like a negative 4 to the 3rd power times an x to the negative 6 power. Okay? That's one way to do it. I guess I could have done it a different way. It's going to work this way. Actually, I probably should have done it a different way. Let me do it a different way. Or you want me to keep going this way or do it a different way? You want me to move the x first?
Let's do it that way.
Move the x first?
No, the way
Okay. So this is not bad. So I'm going to get a negative 64. Where did I get the negative 64? Negative 4 times negative 4. And then I'm going to move the x to the 6 down. I could have done it a different way, like negative 4 over x2 cubed, and I would have gotten the same answer. Can you see that? I don't want to confuse you, okay? Now, I'm going to get some graph paper out. Anybody need graph paper to do this next part? I need some graph paper. Anybody need graph paper? Yes, no? Okay, graph paper, Camille, there you go. You're welcome. All right. Hopefully you guys have your journal with graph paper in it. So, number 7. All right. Here's what I need. So I need 3 things, right? I need 3 things. On number 7. My y-intercept is negative 5. Now, one of the ways you can do that is if x equals 0, you'll get the y-intercept. And you can, check your calculator out if you want to. So, well, negative 5, 2 to the power of 0 is a negative 5. So I'm going to start at negative 5. I'm going to go 1, 2, 3, 4, 5. Then you double that, negative 10. You double that, negative 20. So the graph's going to take a dive. So I'm just going to graph it like this. So I need 3 things. First thing I have is the correct y-intercept. The second thing I have is the correct shape. It does go down. It gets more and more negative. It's exponential growth, but in the negative way. Scott?
So why isn't it positive when you're multiplying?
Great. In fact, one of the things you can do is if you're not sure, remember how we plug numbers in? So I'm going to show you 2 things, okay? Negative 5 times 2 to the 1 power. Negative 5 times 2 to the 2 power. See how it's getting bigger in the negative direction? Yeah. And think about this. You're going to double it. You agree with doubling it? Yeah. So start at negative 5 and double it. Double negative 5. What do you get? Double that. What do you get? 20, right? So it gets bigger. So again, if you get stuck, just start plugging numbers in and you'll see where it goes. Yeah, Gretchen.
So if the y-intercept is negative, then it's decaying, and if the y-intercept is positive, then it's growing?
Not always. Not always. Because this one's growing in the negative way, okay? Right? I'll give you an example of something that grows in a negative way, okay? The national debt. How's that?
Would you call this a growth?
Yeah, I'd call it growth. I'd call it negative growth. I would call it growth, okay? Yeah, it's bad growth, isn't it? I mean, okay, or think about this. This could be bad growth in the fact that, well, I need a negative value. So, like, for instance, a debt, right? Your growth is getting bigger, but in a negative direction, right? That's negative growth. Decay would look like this.
Because isn't that the same thing as
You're getting closer and closer to 0. Right? You're getting closer to 0, right? So if you're approaching 0, you're getting smaller and smaller and smaller and smaller. That's decay, right? As x gets bigger, you're getting smaller. Okay? Good question. Really good question. This is growth, but it's growth. It's negative growth, which can occur, right?
Yeah.
Negative growth is real in our world. It's very real. Sometimes not a very good thing. Okay, so now domain. Domain and range. Domain's always going to be easy. Domain's what? All real numbers. And range? Well, I didn't put my asymptote in, but I really do have an asymptote right here at 0, okay? This graph is eventually going to come up and get closer and closer to 0, right? So my range is going to be y is less than 0, okay? And this is negative growth, but it is growth. Growing in a bad way. Okay, number 8, y equals 48.5 to the x. All right, so where's my y-intercept? Where do I start? Where's my y-intercept? 48, right? So I'm going to go probably by, I don't know, I'll go 10, 20, 30, 40, 50, there's 40, 48. Again, I just need the correct shape. I need the y-intercept, the correct shape, and I need the intercept, okay? Now, if you're not sure how to do this, you can always use your calculator, right? I can go 48 times 0.5 to the 1 power, 24. 48 times 0.5 to the 2 power, 12. So actually it's getting smaller, isn't it? So my graph should look like this. And you don't have to be perfect. I just need, again, 3 things. The y-intercept, the correct shape, and the asymptote. The asymptote's important. Yes, Gretchen?
Is that decay then?
Yes, this is decay. Absolutely, because it's getting smaller, right? It's approaching 0. So if it's approaching 0, that's decay. So yes, good job. That is decay. Our domain, that's easy. What's our domain?
All real numbers.
Yes. What's our range? Greater than 0. Good. Awesome. 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 Yes, Scott.
Is it ever different than that?
For your domain, never. Not unless we do a real life problem, okay? A real life problem would be like this. We start with,
Would you add the like boundaries on it?
yeah. And so that's one of the reasons we want to talk about domain is when you get to a science class, I mean, if you start with a dish of bacteria, you can't have negative bacteria, right? So the domain would be different, right?
Yeah.
So.
And then for the range, it's either less than or greater than 0.
Right, and then even that, you'll get, if it's an application, let's say you're talking about cells, you get to 1 cell, can you get to half a cell? It's impossible to have half a cell. Mathematically, you could have half a cell, couldn't you?
Yeah.
Mathematically, you could have a fourth of a cell. But a real life application, you couldn't, could you?
Okay. But
Yeah.
for these, it's most likely just going to be y is greater than 0 or y is less than 0.
Right, unless we move it, which we will do in Algebra 2, okay? And we're not going to move it, okay? We will do that in Algebra 2, we'll move things, okay? And then it does change. All right, number 9. Oh, that's a different graph. Number 9 is a absolute value graph. Let's see if we remember how to do that. So, we know it's the V, correct? Absolute value graph is the V, correct? We have a vertex. My vertex is at positive 2, 5, right? It's the opposite of the inside. So I'm going to go to positive 2, 5. Let's make the graph bigger. No, that one. Okay, well, I'm just going to do 9 over here. I can have room for it. Here we go. 2, 1, 2, 3, 4, 5. Put it right there. I have a slope of 2/3 up 2 over 3. 2 up 2 back 3. Here's my absolute value graph. Okay, remember that? So, domain. Say it. How wide is this graph? Yeah. It's forever wide. What about the range? Well, what's the lowest height?
Greater than 5.
And equal, right? Greater than or equal to 5. Because it starts at a height of 5 and goes up. Good job, Tava. How am I doing? Okay? Does this make sense? All right. Number 8. We're going to graph a piecewise graph. And I know we can do this. We've done this before. So I'll go through it slowly again. First thing I like to do when I graph a piecewise graph is graph the boundaries. My boundaries are x's, so on the x-axis, I'm going to go to 2, to 4, and to -2. So my boundaries are going to be, and they're invisible, but I like to use a marker because it helps me. It helps me because I know where to put my graphs, right? Okay, the first graph is y equals 2. You know, f of x and y are the same thing. Y equals 2. Well, y equals 2, that's a horizontal line. But we're going to put it between 2 and 4. We're not putting it over here this time. We're putting it between 2 and 4. We're going to put it here. So y equals 2 has a height of 2. And it's a horizontal line all the way across, except it's not all the way across. I only want it between 2 and 4. So it goes right there. Close circle, open circle, close circle, open circle. Graph 2 is a y equals a 3/2 x. All right, I'm going to put an invisible number in. That helped me, plus 0. It just tells me the y-intercept. So graph 2, y equals 3/2 x. So I start at 0. And we're going to go up 3, 1, 2, 3, over 2, up 3 over 2, but down 3, back 2. And the line would go all the way like this. But I don't want all of that. I only want the part that's between -2 and 2. So I'm just going to go like this. They're not connected, but they don't have to connect. Okay? And I'm going to have a closed circle and an open circle right there. Closed circle because the equal, and open circle because there's no equal. How am I doing? Am I going too fast? Am I all right? Okay, let's get the last graph. So the last graph is, graph 3 is y equals -4. So that's a horizontal line at -4. Okay, y equals -4. It's a horizontal line at -4. Okay. And it goes all the way across except for we only want this graph less than -2. So instead of all of this, it's just going to go like, like this. And I have an open circle. Interesting. Open circle again. 2 open circles. That works. Still function. All right? How's that? Can you do that tomorrow? We've been doing piecewise graphs for 3 weeks now. Hopefully we can do it, right? Okay, moving on. Number 9. Okay. Find the inverse of f of x equals 1/3 x plus 1 and graph the inverse. So let's graph both, okay? I think if you graph both, it's really helpful for a lot of you. So first of all, let's graph f of x. And I'm going to use colors because colors are cool. Colors are nice because you can see them, okay? All right, so I'm going to graph that one first in blue. All right, it has a y-intercept of +1 and a slope of -1/3. So slope of -1/3 is down 1 over 3, down 1 over 3, okay? That is f of x. To do the inverse, probably the easiest way to do this is just to switch points. It is the easiest way. I have a point at 3, 0. I have another point at 0, 1. to do an inverse, we just switch them, right? We'll go to 1, 0, which is here. That's 1, 0. And we'll go to 0, 3, which is there. And if I connect the dots, I'll get this graph. So the inverse has an equation also. Do you want me to slow down for a second? Yes? No?
Yeah, 1 second.
Okay. So there's two ways to get the inverse. One is you could do it with algebra, and I'll show that. Algebraically, for me, I just do it algebraically. You don't have to. I'd minus 1. I'd multiply by negative 3. Or, that's one way to do it. Or since it's a straight line, we could use our y equals mx plus b. And I know the slope is down 3 over 1, down 3 over 1. And it has a y-intercept at 3. So I got the same answer twice, either by the graph I just drew or by switching the variables and solving for y, okay? Both methods work. Okay. Give me thumbs up when you're ready for me to move on. Okay. Last but not least. You buy a car for $12,599 and it has a yearly depreciation rate of 8%, okay? So I'm going to start with this equation. Y equals A1 minus R to the T. And of course you're going to tell me why I put the minus there, aren't you? Thank you, Gretchen. You were going to say that, weren't you? Thank you, Gretchen. Now, of course, you're going to tell me exactly. I know you're going to tell me why. Come on now. Obviously, right, we agree? It's got to be minus, not plus. Okay? R is 8%, but we're not going to put 8 here. What are we going to put? 0.08. Okay, and I'll write that down. Okay, so 8%. Same thing as 0.08. So I'm going to rewrite it. I want write a function. So I'm going to go, okay, y equals 12,599. 1 minus 0.08 to the t power, okay? There's my equation. So now, we can use this equation to find out what the value of the car is in 2.5 years. Hi, Giselle. You want to grab it? Yeah. Yeah. Uh-huh. So we're going to go y equals 12,599, 1 minus 0.08 to the 2.5 power. Now you're going to need a calculator, right? Okay, so I use my calculator. Clear. I'm going to go 12,599 times 1 subtract 0.08 to the power of 2.5. Okay? Boom. Okay, the car got less. We lost money on it. So the car is actually worth $10,228.35. Okay? All right. Now, when will the car be worth $3,000? Now, this is a little bit harder to do. This would be more like an extra credit problem, but there's a couple of ways to do it, okay? You can't solve for t. You can't. We don't know logarithms. We're not going to learn logarithms until we get to Algebra 2. So I'm not going to do logarithms, so we're going to guess and check. So it might take a little time, but give me an idea. What do you think? If after 2.5 years it was worth this, give me an idea, okay? Give me an answer. How many years do you think it'll take to get to 3,000? Anybody?
7 years.
7 years. Let's try it. So I'm using my formula, Scott. See, I'm using my formula to the 7 years. Oh, not quite. We need more. How many years?
20.
Let's try 20. 20 years is good, okay? So you see how I'm going to do it? So 20 years is too many years, right? 17? 18, okay.
Maybe 7.
18's close.
17.
17, let's try 17. I'd go 17 years. So you see how I had to do it? Was just keep trying until I got it. So I'm going to go along with 17 years. Okay, good job, you guys. Next year I'll teach you logarithms. Sounds terrible, doesn't it? Logarithms, but logarithms will solve for it. But you don't know logarithms yet. So this we can do is guess and check, right?